Okay, we are live and we have big news. No, great news. No, massive news, right? We removed one of the main obstacles that might prevent some people
Massive
from
news.
adopting
We
Crossplane. Oh, wait, I hear echo. There we are. From adopting Crossplane, and that obstacle is resource coverage. Now we have 100% resource coverage for AWS, Google, Azure, with infinite number yet to come. And today I have two of quite a few people who were heavily involved in creating that something, and they're going to tell you all about that. But before they do, since this is a big celebration, I have champagne bottle over here, which we are going to open. No, I'm going to open. They're not going to open. Oh, double. There we go. I'm going to get drunk. They're going to get full of sugar during this presentation, during this webinar.
Cheers, guys.
Big thing, the
Cheers.
biggest thing we did in this year, without a doubt.
So far.
Biggest launch this year.
No doubt. Okay, so the project is called Terrajet, and let's talk about it. What is it? How does it work? When do you eat it? When do you drink it?
Well, I guess I'd like to start with kind of getting everyone involved who were starting, who were working on it. Maybe Victor, I think we had a picture beforehand.
Yes, we do. If I find it, here we are.
Yeah. So this is just first of all a shout out, right? This is the awesome engineering team behind it. Muvavak, Hassan, Sergen, Alper, and Ezgi. Awesome engineering team out of Istanbul. There's quite a few others, like for example Nick, that helped a lot on the strategy and the implementation. But first of all, it's just Muvavak and me sitting here, but it's a whole village, kind of Istanbul village that has been implementing this, and it's quite a ride, and we're super stoked for the announcement today.
So let's announce it. What is it?
Yeah, so what we're announcing today is basically our code generation pipeline called Terrajet, and with Terrajet, what you can do is you can create crossplane providers. So in the grander theme of things, Crossplane is a tool to manage your cloud infrastructure, and we can talk a little bit about the details of what we think about it as in a control plane, etc. But the important point is you need to connect it to something, right? You need to connect it to your cloud resources like AWS, Azure, GCP, but also to other databases or message servers or whatever you need in your application, and you build your declarative dependencies in your application that defines this. And for a very long time, we've been building these providers, and also, again, Muvavak and others, they have been doing a tremendous job with the community of building up these providers. But we very, early on saw that creating these providers, takes time, right? And companies have been investing in this previously, right? They have created other means of attaching to these services. And one very prominent example is obviously Terraform, right? With Terraform, people are provisioning their infrastructure. And while, Crossplane has some different properties, people want to, reuse of what they've been, investing in before. So, we decided to, look at Terraform, look at the existing Terraform providers, and see how we can leverage the community's efforts in these projects, and build this Terrajet generator that basically takes a Terraform provider, does, from my point of view, Muvavak will tell you more, but from my point of view, does some magic, right, and creates a crossplane provider. So basically, what we're announcing today is that whenever there is a Terraform provider, there's also a crossplane provider. you might kick off the generation and you might do a little bit of tweaking, but it's a matter of hours now to create any kind of cross-plane provider. That's exciting, right? No?
That's very exciting.
Yeah.
Very exciting. How much it would take us to do the same thing if we didn't build Terrajet? Probably years, right?
Years. Yeah, definitely. I mean, we've been at like one of the native providers, AWS provider, has now like 120 CRDs, and it took us like a few years to get there. And like it's accelerating, but still not as fast as like just like getting the code generated and running with it. Yeah.
Okay, and how about implementation? How does that work behind the scenes? Well, my understanding is that from user perspective, there is no significant difference whether a person uses what we call Crossplane native provider or Terrajet provider. You're simply defining your resources for AWS, Google, Azure, or anything else, and everything is transparent, right? Now, what's happening behind the scenes? How does that work?
Yeah. So if you look at a provider that is generated from a Terraform provider using Terrajet, from files perspective, you won't see any difference at all, almost. Like, the files are like, APIs folder and controller folder, just like any other Kubebuilder based controller or any other Crossplane provider. You will see the exact same files and exact same function calls. So the difference is that the files that you're going to see are completely generated using information from Terraform schema, and the actual controller that reconciles those objects, it is a generic one that is configured per resource, and that configuration is also generated. So you will see, for example, in native providers, you would see like setup controller function and then the controller implementation. But in Terrajet providers, you would only see the setup function that just configures the generic Terraform controller, which then calls Terraform CLI in order to like operate. For example, the Terraform apply, it runs Terraform refresh to see whether there is a change to be made, and then calls Terraform apply and all that stuff. I mean, we have built like a few layers there. The controller calls our Terraform client, which we built around like workspace and workspace store concepts, so that like it is not bound to like file system tightly. It's all ephemeral and all that stuff that we will go into detail in our dive deep blog series. But at a high level, it generates all of the files with Terraform schema, but also accepts your configuration that is used for like the references and other features of Crossplane that we will hopefully get into today. And then it's the generic controller in the runtime running all those things. So from users' perspective, or even from developers' perspective, like, a lot of things are similar to others. It's just that like, underlying in the runtime, what controller runs in the underlying is a little bit different than the others who call APIs directly, but in our case, we have a single client and we call Terraform.
Yeah, and I think that just one just from my point of view, from a high level point of view, I think it's also important for those who are not super familiar with Crossplane is that we're talking about these specific provider implementations, right? So Crossplane itself also has this notion of composite resources, and the way we reason about this is that we're actually saying these specific cloud resources that we just talked about, like talking to an S3 bucket or something, like instantiating one of these, is that is kind of like an implementation specific detail, and it's super important, right? Because obviously you need to attach to this. So this is why we're so excited about it. But for any kind of like platform builders, there's a higher level abstractions, what we call composite resources. And there you kind of like stitch these, individual what we call managed resources from these providers. So like in a 3-bucket RES instance or whatnot, whatever resources that we just enabled. And you are able to create these abstractions that then developers can use. So while we're talking about the implementation details, and I'm really like looking forward to hearing more about Mubawak, about the implementation details. It's also important that from an abstraction point of view, the platforms or the abstractions that people build with Crossplane are on a higher level. And we're talking about one of the implementation specifics about these different providers. And here we've, with Terrajet, it's kind of like one way to create the providers, right? We have people are using, Go SDKs. People are using, different REST APIs. And here we have now one way where we can like basically just take a Terraform provider and reuse it.
Yeah, exactly. I mean, on point. Like, from users' perspective, it doesn't even matter. Like, from developers' perspective, it doesn't even matter. Like, what managed resource or provider the operator has built their composition with, so they can even change from native to Terrajet-based provider in their composition without even developer knowing it. So it's all actually in a lower layer of the stack that a lot of our users wouldn't really need to care.
That leads me to an interesting situation, to say the least, when we implemented the first set of resources through Terrajet providers, put them all as separate custom resource definitions into Kubernetes, and then funny things happened, right? Discovering how reaching the limitations of Kubernetes that probably not many reached with CRDs, right? Truth be told, other people reached other limitations, but this is one of the first. You want to talk about that?
Yeah. I mean, that was super surprising to all of us. I mean, in the prototyping phase, we have discovered that after around like 300 CRDs, you can actually break GKE, for example, or most of the cloud provider Kubernetes implementations, because the resource usage of API server would just rocket, and then you would get for 30 minutes no answer almost from API server because of the aggregation of those schemas. And then we had actually that was an alarming situation, because with Terrajet providers, right now AWS provider has 763 CRDs. Azure has I believe around 650, and GCP around 400 or 450. So in all cases we just exceed the number. So we were we were kind of alarmed about it. And then after getting in touch with upstream community, Kubernetes community, and we still have contributors in our community. So we got aware of a fix about this process. I mean, a PR that does not directly address this problem, but it actually solves it. We had several performance tests and validation, and identified that that PR actually solves the problem. And then we worked through getting it included in the 1.23 and the patch releases of the supported minor versions, and it worked. We were able to get it included in the upstream Kubernetes, and today when you go to a release note of any of those full set versions, which we'll get into, I believe, in the next couple of minutes, you will see that a bunch of Kubernetes versions actually now are able to take the load. But meanwhile, right now we know that not everyone is on the latest version of Kubernetes, even though we fixed it. We published 2 versions. One is the standard version with around 100 CRDs, and the other one is full CRD set with the highest number that I just mentioned, 700 and stuff. So yeah, we actually broke Kubernetes and fixed it.
That's so cool to have in your resume, in your CV. I broke Kubernetes and I fixed it, right?
Well, to be fair, I wasn't the one to fix it, but yeah, we have accelerated that process by a lot.
So it is summary so far, and correct me if I'm wrong, right? Whether people use Crossplane native or Terrajet provider is more or less matter of choice. It's transparent what is happening in the background and so on and so forth. From the user perspective, you just use a provider, you define Crossplane resources as you would normally do. You can mix and match. You can use resources from either of the two providers together, or you can choose to use only one of those two providers. I mean, for a given vendor, and so on and so forth, right? Now, is there a reason why I would choose Terrajet over native? Beyond the obvious, beyond the, hey, Terrajet has resources that native doesn't have.
Yeah, but I think that's the important part to start with, right? A lot of people are seeing these roadblocks of saying, okay, I want to Crossplane is really interesting. Now I want to test it, right? We do have customers who are going in production with this, but a lot of people are approaching Crossplane saying this is the right model, and they're testing with one resources and the other resources, and then they're stuck, right? Then they basically can't proceed. And with the three big providers that we've created, they're not stuck anymore, right? And that's a really, really, really important point to reiterate, because there's a lot of other things that people need to do to get into production, right? It's not only the specific resource, but there's lots of subsequent things that we're seeing with our customers to get a Crossplane installation production. But the first step is now done, right? You can use any resource that Terraform has support, and you can use it and get your feet wet, get thinking about the architecture. What does it mean that that developers are now able to declare their desired state and the of the infrastructure that they need, right? They can create a claim saying, I want this specific type of databases that my platform team previously has chosen to set up and build, so that I can really just declare my dependency and everything is done automatically in the backend. So I think it's just important to reiterate that independent of the implementation, we had just removed a big roadblock. Now, if that roadblock is gone, now we can think, okay, now I'm I've been using all these resources, right? And now I want to really double down on it. I want to move this into production. And I think the important part here to reason about is that we are, from an Upbound or general from a community perspective, we are thinking about these resources individually, right? So every single resource has its tweaks, and we have generated a whole bunch of it. But we're also doing QA, internally, but also with the community, with our customers, to move every single resource into a stable state. And the advice that I'm currently giving is give it a try. It doesn't matter with which provider. And then once you have a coverage and you see these providers, let's talk through the resources that you have. Yeah. Either way, right? We're going to support both, right? It's a matter of going with a jet provider to choose a couple of resources, or going with a native provider. It's at the end of the day an implementation detail.
Yeah, I mean, one thing to add to that is that, for example, I have seen community users that they use native providers, all the resources that they want are supported. But what they're concerned with is that, what if tomorrow I have a new product, I have a new application that needs this other obscure service of that cloud provider? So that's a problem for them. They would like to know, how fast they can get support for a service that is not supported today. And for example, if they don't have anyone writing Go or proficient in how Crossplane works and stuff, they get stuck. and like we help them, but the process itself takes long. With Terrajet, they can be confident and say like, hey, this resource, for example, is still like in its v1 alpha 1 state, let's say, but it exists and it's there. I can try it, I can test it, and I can let the contributors or like maintainers know that I'm using it, so that we can make it like better resource by configuring it. So it's that like that confidence is really I think important for community, that adding a support or like having a beta level support for a resource, or even v1 levels support for a resource is way easier today, even if you don't know like Go or like other stuff.
And it's
How
also
about
just
oh,
sorry,
go ahead.
yeah, sorry, Victor. One thing to also point out is that I've started to talk to a couple of other vendors, and who don't have Crossplane support today, and they're seeing this also as just a great way to get started with Crossplane, but also keep maintaining Crossplane, because they're just not like, they don't have the resources from the get-go of fully investing into Crossplane. They see it as a chance. They want to be part of it, and they want to invest it, but they basically say, oh, well, we cannot provide a second or cannot create a second provider. And this is like the perfect setup. Is okay, that's perfect. Build a great Terraform provider, and include the jet generation in some automated way, and then you have both, right? So in that way, where you're able to control both providers, you have the perfect the Terraform provider and the Crossplane provider. You have a perfect setup where you can like basically choose of what happens with a minimal effort, right? In other situations, and we alluded to that earlier, you might not want to depend on an upstream Terraform provider, right? Because the Terraform provider has a bug, all right, or it has a way of configuring that resource that doesn't really suit you, right? So you might want to fix it. Now, in a native providers, you're more flexible, obviously, right? You can do all sorts of things. So there's no right or wrong answer, right? These are two implementation details, and it really depends of your concrete use case and where you are in the larger context. And I'm expecting that we'll see just a very large set of jet providers, a few native new ones, right? So I'm expecting that we see both, a lot of providers in both implementation details.
Yeah, I mean, just to add to that, we have right now like around 10 jet providers, and we have like as like I believe as Upbound, we have built only 3. Like the other 7 are completely built by the community members, and some of them by the vendors. So it's picking up.
Exactly. Speed is
Yeah.
the key here, right? It helps us do things much faster, and more importantly, it helps community contribute more, right?
And
Including
maybe a
vendors.
shout, yes, totally, and maybe a shout out to everyone listening, right? We're all in early at this, right? There's obviously there's certain type of users and our customers who are really early on and are exploring this, and we're really happy to work with this. But a lot of folks are experimenting with this. So don't hesitate, start experimenting. Reach out to the community where there's a lot of really great people, and figure these things out. And again, that's what the nice beauty is. As of today, you will be able to have a much larger set, if not the total set, if you create the provider of using any resource that you like.
Guys, there are a few questions. Should we jump and answer them? How does that feel?
Sure.
Good.
Yeah.
Okay. No, without filters. First of all, a bunch of comments congratulating us. Thank you so much. But as Matthias said, this is not us only here. There is a much bigger team in Upbound and the community. So really, a lot of people chimed in, right? Helped out. This is and How long? Wait, how long? How far ago did we start? It's been only like 4 months, right?
I believe we have started around third quarter of 2021, and then like we have arrived at a point where we got stuck with Kubernetes problems, and then like until we fixed those problems, we kind of like uh, that kind of decelerated the process. But I believe in total, like the active working time would be something around that in general overall.
To me, those dates are extremely important because they really demonstrated the speed that Jet Provider enabled us. Right? It's been months basically since we increased the coverage to 100% on 3 providers and then 7 more. Right? So on and so forth. So.
Yeah, I was actually thought about like how you asked that like the whole Terrajet project and like when we started working on it, but the actual provider coverage getting to 100%, yes, it's been a few months.
July
Okay.
30th. July 30th was the initial commit by Movavak.
Now, for everybody listening, now you know which one of the 3 of us is a manager. Huh? Just to stress that out.
But the point, but I think the third quarter is where we heavily invested it, and exactly as Mubarak said, the performance challenges were taking much of our time in the fourth quarter, and just to reiterate on that, I'm really stoked working at a company that breaks Kubernetes and fixes Kubernetes. I'm really this is some really great things that we're doing there.
And one thing I would add, one thing that I really like about where I am right now, the company we're in, and so on and so forth, is that emphasis on open source, right? We're not shy from using other projects. It's not closed. And we are not shy from fixing things or contributing to other projects like Kubernetes in this case, right? And to me, that's really impressive. Not being focused only and exclusively on your, on your stuff, but looking at the bigger picture.
I mean, and this isn't the first time. Like I don't know if folks remember, back in the time when we implemented composition. In the composition there are XRDs, and we generate CRDs and install them in the runtime, like on the air, and we spin up new controllers for that. That wasn't actually possible, for example, in controller runtime of Kubernetes. And Nick, shout out to him, like he patched controller runtime to enable this use case of like starting up controllers whenever you want in an up and running controller manager. So like as you said, like as a company we do, and also as a community we do follow like all those open source standards and just contribute wherever we can.
Okay, here's the first one. Who wants to take it? Any plans for generating a provider from an open API spec? I think I know the answer, but I'm gonna let you answer it.
I think I can take that one. So any plans right now? Our long-term plan is essentially like getting vendors own their provider, right? So for example, AWS, GCP, and Azure. Azure, I believe, has an open API spec published. So our aim is to make it easier and like more maintainable for them to own their providers. And if they choose to do like to do so, like if they choose to generate a provider from an open API spec, then we will help them. But I believe like each of them like in their own unique conditions and in their own generation they have their own generation pipelines. So I believe like they are the ones actually doing this choice for them. For example, Google has its DCL library and magic models for generating stuff based on that. So I mean they might go with that. So it's like as long as it's compliant with Crossplane resource model, and built on Crossplane runtime, all is like fair game, I would say.
Yeah, I guess my PM question would be, Mohammed, which API are you targeting at? Maybe you can write that in the chat, right? I would be interested as what your use case is, right? As always trying to figure that one out. And maybe one important addition or re-emphasizing what Mubavak has said is, we want to, at the end, right, the long-term game plan is that the providers are owned, the Crossplane providers are owned by the cloud providers, right? And everything that we do is basically is enabling this process, right? With Terrajet, with other tooling that's up that will be coming. So the end is that there's a certain conformant Crossplane providers. And we're working on a conformance program, etc. But basically, everyone is kind of like publish their own Crossplane provider, and that way they can interact or implement them, hook them onto some generation pipeline based off Open API spec or something else, and really make sure that they are providing the API like how they are seeing to be that their API is consumed. Right, so that's just a long-term thinking. But Mohammed, let us know which provider you're targeting. I would be interested.
Okay, this one I think I will have to answer simply because there is misspelled name of mine over there. So Victor, can composite resources be an alternative to Cubevela? I would say yes. So functionally, there is a lot of similarity between, let's say, Crossplane compositions and Cubevela itself, or at least the initial part of Cubevela, because now Cubevela is moving into other areas around the application management and so on and so forth. But yes, both are designed or have features or enable certain groups of people to compose resources into something that is easier to manage by others, right? Let's say shift left, right? Enabling developers. For example, you're an ops person, you want to enable developers, and you can use Cubevela to say, hey, when somebody says this is a front-end application, that person can write 10 lines of YAML, and as a result of that, the outcome will be that deployment will be created and a horizontal pod autoscaler and ingress and virtual service and what's not, right? Abstracting complexity or hiding complexity and exposing things that matter to, in case of Cubevela, to developers, right? Crossplane does the same thing conceptually, except that in Crossplane it's called compositions. Crossplane allows you to compose any number of resources from many providers into a composition that is very, very easy to use for end users. One of the major differences is that we are very much declarative oriented. So you write YAML that you're patching, while Cubevela is using Q, which is programming language which I believe originated in Google. So there is that difference. And of course, there is a difference that Crossplane is focused on being a control plane of everything. So theoretically, assuming infinite coverage of everything, Crossplane allows you to compose anything. It could be AWS resources, it could be Kubernetes resources, which you translate into applications. It could be, I don't know, Git repositories, Datadog, and so on and so forth, right? It could be anything, and that includes applications and infrastructure and services, while Cubevela is focused almost exclusively on applications, right? That's the difference. But conceptually, yes, and in practice, without going into details, what is better, what is worse, Crossplane you can create Crossplane compositions that contain Kubernetes resources, and then you get something that can be called an application. If I or anybody else does not answer fully or misunderstands the question, just continue asking. This is a comment, I think. Okay, yeah. Unix player is breaking the API. There is nothing more satisfying than breaking things. That's why, among other things, I love chaos engineering. Kind of like you get paid to destroy things. It's beautiful.
Yeah, actually, on that note, today I saw that GKE released 122.4, which contains the fix, but I couldn't get a cluster with that version. So, yeah, it's getting there.
Yeah. So that's the answer to Mallory's question, right?
Anyone have the version for the old case? And yeah, so if you go to any of the Jet-based providers release notes, you will see like a big warning there saying like, hey, use this version only if you are on these versions. For example, I mean, obviously 1.23 and higher, they're all compatible. And for 122, it should be like 122.4 and upwards, and so on and so forth. So you can check any Jet provider release notes to see like which version intervals are can support that many CRDs.
Okay. I think we partially answered this one. I don't know if anybody wants to give additional thoughts or more info. What is the difference between the old version and the Terrajet version? Why should we care about the old one? I think the second question might be the more important one.
Yeah, I mean, we're talking about this all the time, so I'm wondering if we talked about this before the show started or during the show. So I'm just going to reiterate. Care about the provider that has your resource coverage, right? Those that has your resources that you need. Care about this one. Give it a try, work with it, and see if it satisfies you. Again, it's two different implementation, but it's an implementation detail. One is directly using Terraform, so it's like a broader range of coverage, and the other one is just hand waved. And in the hand wave part, it's just there are certain things which are easier to get around. That doesn't mean that the jet provider is not suiting you. So if there's resources that are not in the native one, go with the new one. If there are if you see problems with that, create an issue or let us know. But we just had one example the other day where that I think Hassan was building this. And it had an upstream issue in the Terraform provider. I think it was GCP. Correct me if I'm wrong, Muavak. And
Yeah.
Yeah, it was GCP, right? And basically, there was an upstream issue in Terraform, and fortunately, Hassan was able to actually fix it upstream, get it in the Terraform provider, have that one merged, and create a release for the generated jet provider. So awesome, right? That's like all the bits and pieces. But you can imagine, obviously, scenarios where the fix is not fast enough, right? Or the fix even upstream is rejected because of strategic reasons for working with the API in a certain way. So in that case, the quote unquote old one, the other implementation, could be a suitable exception or a suitable a version to choose.
Yeah, and also I would add one more thing to that, like both of the implementations will be supported in the long run, like I mean for years to come. So it's safe to depend on both of them as long as the usual Kubernetes version guarantees are held. About the bug situation, how we depend on Terraform provider. So right now we prefer to fix it in Terraform provider, right? We prefer to fix it for everyone as much as we can, and whenever that is not possible for some reason, at least in the implementation wise, we have some more choices in Terrajet. We can just switch out the controller with a manual implemented one. We haven't needed to do that yet, but it is possible from code perspective that a jet provider one exception and we replace the controller with a handwritten one, because for some reason we just can't get the Terraform provider work for us.
Here's one that you two will like a lot. Can we choose to install just specific CRDs at Kubernetes client side, cluster side?
I'll start, and Mubarak, you continue with your thoughts.
Yeah.
So we've been debating this, but at the end, the current implementation, and this is an open source community, right? So we've not only debated this internally, but also with the community. So feel free to join the discussion. But at this point, the way we're seeing this is that Crossplane providers and the CRDs that are installed are kind of like describing the API that you're able to choose from, right? So any platform builders should install the providers that they have and mix and match the actual CRDs that they use. And by shifting this decision which providers to use beforehand of only subsectively choosing the CRDs that you want to install, we're kind of like making a couple of downstream use cases a little bit harder, right? For any platform builders to add a new CRD, that at that point you would need to install the new provider with something new. So I guess the way we're currently approaching this is basically saying, you need to get Kubernetes, and this is what the team has been doing, right, in a very, very great way, is allowing to install all the CRDs that you potentially will need. Now, will there be a future where you can filter providers with a couple of CRDs? Maybe. The performance is not really the major or a major concern currently. There's still some issues, but the majority we have fixed. But our stance is get all the CRDs installed so that the platform team, those who are stitching the compositions together, have all their means now and while they start adapting these.
Yeah. I mean, as Matthias just pointed out about performance problems, currently from our performance stance and the whole validation suites that we have run, the number of CRDs does not have as much effect on the API server anymore, because those fixes about open API aggregation has made it. But there are some client side warnings, for example, printed by kubectl, which is unnecessarily hey, because of the number of the CRDs, discovery client makes hundreds of calls, but for 10 minutes it doesn't make them anymore. So there are certain impact on the user experience when you depending on the client that you're interacting with. But from memory, CPU, or responsiveness, there are client side latencies, but not any server side costs to you. So what we're aiming for is essentially continuing on following up with the upstream to make the discovery client better for cases where there are just thousands of CRDs in the cluster, because that's the future we believe in. We're going to be the Kubernetes API, the control plane would have hundreds and thousands of CRDs that you can compose and then provide your own abstraction on top of that. So we are fixing them, but the assumption right now is that the performance impact is minimal, and we will also follow up to fix even those minimal effects.
Okay, not much time left, so let's try to go through the rest of the questions. Where am I now? Yes. The essence of the question is, what is the best way to debug?
Tried it today with Keycloak. What does that mean? Like Keycloak provider you try to bootstrap?
I think so. I saw a new provider popping up today.
Oh, cool.
Yeah, I think I saw it as well.
Yeah.
I guess the essence is that the error output has not really helped me yet. What is the best way to debug?
Yeah, I need to see the error output, but as a high level architecture, like if you're stuck at the generation level, like when you run make generate or make reviewable, you have two executables in your jet provider. One is provider and the other one is generator. So the generator is consuming Terrajet as a Go package by importing it. So you can debug it just like any other program. You can put breakpoints and you can move one by one and see what's happening under the hood. For provider side, you can enable debug flag. If you go to crossplane.io, there's a troubleshooting section. Well, like all the problems that you have during at runtime can be troubleshooted with that guide. But for generator stuff, you would need to see the Terrajet development guide, which has some troubleshooting pieces, I believe, but not a lot. So, currently for generator side, your best bet, I believe, is to do some breakpoint debugging. For provider part, go to Crossplane.io and see the troubleshooting guide. And I mean, you can just write on Slack, and I'm sure someone will chime in, or we will chime in.
Create an issue, Florian. Let us know
Yeah.
how it works, what the specific problem is.
Matthias, this is a follow-up to your question about OpenAPI. What are you trying to implement? So we got Harbor as example, or any API-driven database.
Yeah, I would need to look into it. To be honest, I have not heard about Harbor. And regarding API-driven database, we have provider SQL. I don't know if that answers part of the question.
Mhm.
So,
And
go ahead,
I will
Victor.
shame you publicly, Matthias, for what you just said. You haven't heard about Harbor.
All right, that's fine. That's completely okay. Mohammed, why don't you reach or again create an issue so we can discuss or let me know in Slack to
Yeah.
see how we can solve this.
Yeah, maybe yeah. Yeah, maybe I can quickly touch on the challenges about OpenAPI just before we jump to the other question. So the OpenAPI spec provides a lot of functionality and schema for us. But one thing we get from Terraform, for example, is diffing. When you run Terraform plan, it shows you whether an update is needed by checking all of the fields with what's in the state file, which is not covered by OpenAPI. So that is one of the challenges whenever we do code generation, because the APIs are usually imperative and the whole point of Kubernetes controllers are being declarative, right? So that conversion is hard at such hot points. Like diffing is hard, checking whether it is up to date is hard, and by hard I mean you need to go through every field, and OpenAPI does not directly help you with that. Terraform does, or other for example, Google DCL has some client side tools that you can use and other stuff. So OpenAPI is a bit more challenging from that perspective because it's only like a schema. Yeah.
Okay, I think that this next one, Matthias will love the opportunity to answer.
Okay, interesting. Obviously, there is already we have the Upbound Registry. I'll share the link in a minute. But we already have something like this, right? So in Crossplane, you're not only able to create these providers, which are essentially a set of managed resources, combined for certain cloud provider, but you're also allowed to create other kind of what we call configurations. And these configurations are including can include provider dependencies, but also compositions. And you basically pack these together and create a specific configuration package for useful compositions. And actually, we have some AWS reference platform, which you can use. But to be honest, I think we need a lot more there. It's it's very scarce at the moment. That said, another team is actually working on updating the registry, and there's lots of new capabilities coming in, and also working. It will be better working with these compositions. So expect to see something there. Meanwhile, Maxime, if you have a useful composition, let the community know, right? Post it, share it in Crossplane Slack, get rally around it, because it's always great to get feedback. But yes, there will be the Upbound registry will be updated, so there you can have more capabilities of sharing useful compositions.
Yeah, definitely subscribe to Upbound email list to get updates about Terraform about Upbound registry. Oh, you're muted.
Or join Slack.
Yeah.
Here's one which I can answer and then correct me, either of you two. Basically, yeah, those two resources do not exist currently, or did not exist last time I checked as Crossplane native, but they are available through Terrajet.
Yes.
So GCP project is one of the resources in Terraform, and since we covered now all GCP resources, you can create a project as well, or not create, manage, and so on and so forth.
Yeah, exactly. Both are available in their respective jet providers.
Okay. Matthias likes strategic questions. How do you position Crossplane as compared to AWS controllers for Kubernetes, ACK? I can answer whatever you prefer.
No, I'll go. We see so we need to be a bit precise. We're not talking about Crossplane, but let's talk about the AWS provider of Crossplane, and because that's the comparable part to AWS to ACK. And we see it more or less. We see a future where these two things are the same, right? The AWS, the ACK project, or other projects that can generate these CRDs. We see a future where these are compatible with Crossplane, and that at the end of the day, if you are choosing to install provider AWS, you're more or less getting the things from AWS directly. So there's no competition at all. Quite the contrary. Currently, we're working very close with AWS of using the same code generation pipelines that ACK is using to create our providers. There are some gaps, some architectural questions. So we'll continue to have that conversation. But we see a future where basically the Crossplane provider is that you install in Crossplane is the same as an SDK. Now, the important piece, if you are looking at both alternatives, if you're looking at ACK or Crossplane, again, the big difference with Crossplane is that you have these compositions available. The idea of that you can compose these resources into higher level abstractions, which we think is really, really needed beyond any, getting your feet wet, any bigger initiative, because you need to guard down the resources that you're using. You need to provide a specific interface for the developer. You can choose whatever that is, right? But we think this composition part is a crucial addition to ACK, which we would advocate for Crossplane.
Okay, we have very little time left, only a few minutes. So let's try to answer kind of like in one or two sentences quickly. I think, Andre, that the Mubarak already answered this question. Which, yeah?
Yeah, so GK just announced that they have 1.20.4 EKS, Amazon EKS. I mean, we haven't seen the problem much there, so you can use it, I believe, whatever version you would like to. And for Azure Kubernetes Service, I believe they also released the patch version. So all of them should have it by now.
I will lead with the example of how to answer quickly. The answer is yes. Used Crossplane for new resources instead of Terraform.
Yeah.
And I dare any of my colleagues to contradict me now. Do you still need to use Golang development to get things like the external name tied to resources if that work has already not been done?
Get things like some name tied to resources. Do you mean the provider development perspective, or like, getting the external name of already provisioned resources? If it's former, if you're asking like, whether external name implementation can be done in Terrajet, yes. We have a configuration interface that you would need to do, but we have a couple of like, already written external names implementations that you can just tie and use. If it is the latter, like, getting to know the external name of provisioned resources, in Jet providers, you can just use their Terraform ID. For example, I know GCP has like, exported Terraform functionality, so you can just like, get the IDs from there, put it as external name, and then run with it. In a lot of cases in Jet providers.
And the last question for today. I'm asking to know if I can integrate Terrajet with GitOps, Argo CD, and provision accounts and projects. Yes, I mean, you can manage with Argo CD any type of Kubernetes resources, and since everything in Crossplane is a Kubernetes resource, then the answer is huge yes, with the asterisk. There are a few issues with using Crossplane claims with Argo CD, which we are working on it, so that will be resolved soon. Until then, if you temporarily avoid claims, the answer is huge yes to any type of Crossplane resources, including accounts and projects.
Yeah.
And that leads us to the last minute of the presentation of the webinar. Now, few quick notes. And now you need to start, everybody listening, you need to capture the screens and stuff like that. No, actually, Matthias promised that he's going to post the same things in comments. There is a video that was published when this webinar started, in which I walked through using Terrajet from the user perspective, not from the contributor perspective. So as a user, if you want to see how Terrajet works and how actually it is the same as anything else, go and check out this video. This is the link to Terrajet itself. Within that page, within that repo, you will find a link to the three major providers, AWS, GCP, and Azure. Mubarak wrote an excellent blog post, deep dive into Terrajet. It's like TV novella. It does not end with one episode. It will continue for quite a few. He's a prolific writer, and and those are the 3 links or 4 links that you should take away from. You should write down. We will post them in the chat, and I will edit the description of this video to have those links as well. Thank you so much. Any last words, guys?
Yeah, I would like to echo what Matthias has said in the beginning. A big shout out to Crossplane community and other folks that worked on it, like Hassan, Alper, and others in the community and Upbound, and also Matthias. I mean, he didn't call himself, but yeah, he was like the PM of the whole project.
No, stop. Wait, that's absolutely unacceptable. Is Matthias here? Is he in this picture?
He is the one who's taking the picture.
No. Don't give me excuses. Is he here or not? No. So, no credits to Matthias.
That's fine.
Kidding. Matthias was really brilliant in this project.
Yeah.
That's about it. Thank you so much for watching. I finished my bottle of champagne, so I have nothing to cheer with.
Yeah,
I
I'm
will
still
open another one.
working on my Red Bull. My final comment, again, thank you very much for everyone joining. But as always, as you start with these projects, this is just the beginning. Join our Slack, right? Create providers. If you have troubles, reach out. We're very approachable. There are Crossplane community hours. Join those. Use Slack. Use Twitter. Whatever. We're really invested to get the community up and running, right? So we'll we're very approachable. Don't hesitate to reach out.
Yeah.
Thanks,
Cheers.
everybody. Cheers.
See y'all.